Objective 1.4, solving quadratic equations by finding square roots. So our objective for this lesson is to solve quadratic equations by finding square roots and to give those solutions as exact simplified answers. So we've already talked about being able to factor as one of the ways to find solutions, but it's not the only way. And so our next few lessons will be looking at different ways that we can find solutions to quadratic equations besides factoring. So again, we're going to start with a little bit of vocabulary. It starts out by telling us that if b squared equals a, then b, which is just that base of the b squared right there, is going to be the square root of a. It goes on to tell us a positive number a has two square roots, the positive square root of a and the negative square root of a. Now this is important when we are dealing with solving equations, because when you are solving equations, you are interested in both the positive root and the negative root. When we are just evaluating for things like simplifying numbers, I just give you what's the square root of 81 and you just tell me it's 9. In those kinds of cases, we're only interested in the positive. But when we are solving equations, we are always interested in all of the possible solutions, and therefore we have to consider both the positive square root and the negative square root. Okay, so keep that in mind as we move forward. Then they go on to just break down the notation for us a little bit. They tell us that this symbol is called a radical sign, that whatever is inside of that symbol is called the radicand, and all of it together is what we call a radical. Okay, so again, just some vocabulary so that you understand what we're talking about as we go through this lesson. They also talk about rationalizing the denominator, and that is what we do in order to eliminate the square root in the denominator of a fraction. So we're literally trying to take the irrational square root that's in the denominator and do something that makes it a rational number that is better to work with. Okay, and we'll talk about that a little bit, because an additional bit of vocabulary that I've added here is what does it actually mean to have a simplified square root expression? Because you noticed one of our objectives was that we need to have answers that are exact simplified answers. And so there's two criteria in order to be considered completely simplified. The first is that no radicand, so remember that's the part that is inside of the radical sign, no radicand has a perfect square factor other than 1. So if any radicand still has a factor in it that would be a perfect square, then it's not considered simplified. And then the second criteria is that there is no radical in a denominator. So if that's the case, then we'll have to go through this process of rationalizing the denominator in order to be considered completely simplified. All right, so to do that, we're going to use a couple of properties that will help us. So assuming that both the a and the b in this property are positive numbers greater than 0, then we have two properties that we can use with square roots. One is called the product property, and the other is called the, and the other is called the quotient property. So what the product property basically says is if we're taking the square root of something here, which can be split up into two factors, it is equivalent to say that the square root of the product is the same as the square root of the one factor times the square root of the second factor. Okay, those two forms are equivalent. We can also do the same thing with quotients. If we're taking the square root of a quotient, which in this case looks like a fraction, we can split that up to take the square root of the top and divide it by the square root of the bottom. And keep in mind, these properties can go either way. So I can start out with a product and split it up, or I can start out with two things being separate and put them together. And same with quotient. I can start out with the quotient being square rooted and then split them up, or I can have them split up and put them together. It works both ways. All right, so let's actually use our definitions of what it means to be simplified and the properties we've just seen to simplify these four expressions. We're going to start with the multiplication ones. So in the first case, we're being asked to simplify the square root of 99. Well, as you think about what the factors of 99 are, I hope you realize that this is not simplified because 99 can be written as the product of 9 times 11. And 9 is a perfect square. So we're going to use the product property to actually split up the square root of 99 into the square root of 9 times the square root of 11. Now, because 9 is a perfect square, when we take the square root of it, that turns into 3. Notice that only the square root of 9 became the number 3. The square root of 11 has stayed the square root of 11. And technically we are still multiplying these two things together, but since multiplication does not need a symbol, we can just write that together like this, 3 square root of 11. It literally means 3 times the square root of 11, but we don't really need that multiplication sign to indicate that. So 3 square root of 11 is what's considered to be the simplified expression of the square root of 99. Okay, now in the second one, excuse me, in part B, we're looking at the multiplication of two square roots. And although we might be able to simplify the square root of 8, we can't really simplify the square root of 6. So in order to make this work better and to really simplify things as much as possible, we're going to again use the product property, but we're going to use it in order to, back up a step, in order to actually combine our two square roots together. So we're actually going to take the square root of 6 times the square root of 8 and turn that into the square root of 48. And then think about it like we did with the square root of 99. Are there factors of 48 that would be perfect square factors? Now in this case, we have an abundance of perfect square factors. We have 2 of them. We could say 4 is a perfect square factor. We could also say 16 is a perfect square factor. So when you're in a situation where there's more than one choice, you always choose the larger perfect square, because that will take out all of the perfect square factor that you need in one shot. If we only took out the 4, then we would still be looking at 12 as the other factor, and the square root of 12 would still have a perfect square factor in it. So you would have to go through the process a second time. So if you realize that the 16 is a perfect square factor and it's the bigger one, by splitting up into 16 times 3, we'll be taking care of the simplification all in one step. Sorry guys. So we take the square root of 48, split it up into the square root of 16 times the square root of 3. Then we actually take the square root of 16, which will give us the 4. And so our simplified expression is 4 square root of 3. All right, let's take a look at a couple of quotient problems. So in the first case, we have the square root of the quotient 3 over 25. According to the property, we can split that up into the square root of 3 over the square root of 25 separately. Then we can look at whether either of those can be simplified. And we notice that the square root of 25 can be turned into a 5. So we get the square root of 3 over 5 with no radical in it anymore. And because there's no radical around the 5 anymore, we can leave our answer as is. Our square root of 3 cannot be simplified any more than it is because there's no perfect square factor, and we do not have a radical in the denominator. So we're done. This is our simplified answer. Now if we do the same thing with the square root of 36 over 5, and we split them up into the square root of 36 over the square root of 5, we can simplify the square root of 36 to get 6. But that does not take care of the fact that we have a radical in the denominator. So now we need to go through the process of rationalizing the denominator. And so to do this, we need to think, what can I multiply the square root of 5 by so that I end up with a perfect square that I can then take the square root of? And when we're talking about square roots, that's fairly easy because you can just multiply it by itself. So I'm going to take the square root of 5 and multiply it by the square root of 5. But that also means that I have to take the 6 times the square root of 5 as well, because this has to ultimately equal 1. I have to be taking my answer here and simply multiplying it by the equivalent of 1. Okay? That way my answer stays equivalent, it's just going to be in a different form. So we're going to multiply by square root of 5 over square root of 5. And what that does then is that the denominators, when I multiply them together, end up giving me the square root of 25, which I can then simplify to just 5. The numerators will multiply together to just be 6 square root of 5. So my final simplified answer is 6 square root of 5 over 5. All right, take a moment to try a few of these on your own. Pause the video for a moment as you work, and then come back when you're ready to check your answers. All right, let's see how you did. So in the first one, you had the square root of 60. 60 has a perfect square factor of 4. So if you split it up into the square root of 4 times the square root of 15, the square root of 4 can be simplified to a 2, and 2 square root of 15 would be your answer. In B, if we combine the square root of 2 times the square root of 18 to make it the square root of 36 first, then we can simply take the square root of that to get 6 as our final answer. And in C, if we take the square root of the 81 on top over the square root of the 11 on the bottom, then we need to rationalize our denominator by multiplying top and bottom by the square root of 11. And that ends up giving us 9 square root of 11 over 11. All right, now we want to keep this in mind as we move forward with actually solving equations, because our equations have to have solutions that are in exact simplified form. So this little exercise of simplifying these square root answers will carry over into solving our equations. So we're going to go to a Prentice Hall video today, this time with Mrs. Jenkins. Give it a minute to load up here. we go.
Hello there, my name is Mrs. Jenkins. I wanted to give you some help in looking at a topic of solving quadratic equations using square roots. The method of square roots can be used whenever you have an equation of the type where you have ax squared equal to c, a constant, or ax squared plus or minus c, a constant, is equal to 0. Your only variable is the variable, in this case x, that's being squared. Then you can use the method of square roots. To use this method, you're going to solve for the variable, first of all, by isolating x squared. Then you're going to take the square root of each side. Let's take a look at a couple of examples. In our first example here, you see we have x squared. We want to isolate the x squared. To do this, we'll begin by adding 48 to each side of our equation. When we do that, we're going to get that 3x squared is equal to 48. Now, to isolate x squared, we want to divide each side of our equation by 3. When we divide 48 by 3, we're going to get 16. So x squared is equal to 16. Now we've isolated that variable x squared. We can go ahead and take the square root of each side. The square root of x squared is simply x. The square root of 16 is going to be a positive or a negative 4. We do get two answers, positive 4 and negative 4. I have a second example here, and I want you to do your best to work through this one, solving, in this case, for b. We have the variable b being squared. When you've finished working through that, click Continue at the bottom of the screen.
All right, so go ahead and do that. Turn off the video for a moment if you need to while you're working through it. And when you come back, we'll hit Continue and see how you did. All right, let's see if your answer matches.
Welcome back. I hope you were able to find the value of b in our equation. We'll begin by subtracting 9 from each side. And when we do that, we're going to get 2b squared is equal to 0. Now, if we divide each side of our equation by 2, we'll find that b squared is equal to 0. We've isolated the variable b squared. Now we can take the square root of each side, and b is going to have a value of 0. So our answer here is just one answer, the answer 0. Whereas in our first example, we did get two solutions. It is possible that at times you will get no solution. Now, that's a look at solving quadratics. Let's go ahead and take a look at an application.
All right, we're going to pass on the application for right now. I just wanted to show you excuse me, what the process is for solving for those variables using the square root. But now let's expand on that idea to something just a little bit more complex. So here we want to solve 5 times the quantity x minus 7 being squared, which is equal to 135. Now this is a little bit different than what Mrs. Jenkins was telling us, because it's not just the variable being squared, it's an entire quantity right here that's being squared. But the process is still pretty much the same. We're still trying to get to the point where we can isolate this quantity, take the square root of both sides, and then finish getting x all by itself, doing whatever operation is necessary. So if you think about this, sometimes I call this peeling off the layers. If you're trying to figure out what to do or what to undo to solve an equation, think about it in terms of layers. The first thing that's being done to this x, which is what we're trying to isolate, is that we are subtracting 7. And sometimes you can actually even make yourself a little chart called a do-undo chart. And so if you look at this, you can say, well, the first thing I'm doing to x in the equation as it is I'm subtracting 7. Then I take that quantity and I square it. And then that whole thing is being multiplied by a 5. Okay, so if that's what I'm doing to x, then what I need to undo is the opposite direction with the inverse operations. So this multiplying by 5 means I'm going to divide by 5. And then this squaring means I'm going to have to square root, and this subtracting 7 means I'm going to have to add 7. Sorry, 7. All right, so let's do that. So we start by dividing by 5, which gives us x minus 7 quantity squared equal to 27. Then we're going to square root both sides. Remember, when I square root the 27, it is the positive and the negative of the square root. So I put the plus or minus out in front. Now when I look at that square root of 27, I realize that 27 has a perfect square factor of 9. So I'm going to go ahead and simplify that before I go any further and change it into the plus or minus 3 square root of 3. And then finally, to get x by itself, I'm going to add 7 to both sides. Now generally I would say that when you add that 7, you want to put it in front of your plus or minus sign, just so you keep things more clear. Putting plus or minus in between the two terms is a little more clear than if you try to add the 7 on the end of your expression. So 7 plus or minus 3 square root of 3 is the answer we get from this equation. And notice here, there are actually two solutions to this equation. There's the solution you get when you take 7 plus 3 square root of 3, and there's the solution you get if you take 7 minus 3 square root of 3. But for simplicity, if you want to leave it together as 7 plus or minus 3 square root of 3, that's fine. Just realize it does represent two different answers. All right, go ahead and try this one on your own for a minute. Pause your video while you give it a shot. Come back when you're ready to check your answer. All right, so in this case we need to divide both sides by that -2 first. Then we take the square root and add 3. And when it's all simplified, we get a solution of x equals 3 plus or minus 2 square root of 2. All right, so that should give you the information you need to complete this objective. Sorry about that. It's not 5.6, that's 1.4. So we're completing the practice problems for the 1.4 objective. Sorry, this is an old screen here. So your questions, we don't really have class, but you do have email, you do have other resources that will help you answer your questions. And then the checking off, remember, is once you've completed your practice, checking your answers, and then doing the check-in problems on the Canvas. So sorry this is an old screen that didn't get updated, but I think by now you know what the routine is, so it shouldn't be a problem for you. And if you're not sure, check Canvas and make sure you're doing what you need to. All right, I think that's it for today's lesson. Good luck with solving equations by using square roots.